All right. So, yeah. I'm gonna get everything booted up so that we can do this. Share screen over there, and now what we need to do is I need to go and get the thingy. All right. Also, really? Can't plug it in there? Man, the power stuff is like all the way over there. They probably don't want me to mess with anything over there. And let's see, is this working here? Volume is terrible. Let's go ahead and see. Okay, not so terrible, but then it's cutting out on me, which is really weird. Yeah, does it sound like it's just coming in and out and cutting randomly? Sorry. And this won't help with regards to the plus it. Okay, I think this is good. Yeah. Yes, working. Oh, really? It sounds like it is. All right. Let's try this then. Are you working? What about you? How about you? Okay, you're working. And let's see. I believe I just simply take this, pin this here, and point it up. And is everybody hearing that just fine? Okay. So let's go ahead and get this started because we have a lot to do. You know, I have a lot of practice exam to go over today, and I want to make sure I get all of the necessary bits, which we will. I am also busy, full disclosure, writing the exam, and I plan on having it finished, you know, exactly by 9 o'clock tomorrow. So, but no, in seriousness, I was working on the exam yesterday. Some of the questions that I've asked last semester, I'm converting them into like multiple choice. Like, so as I've mentioned, I'm very fond of questions that are like, okay, here's something, please draw it. You know, here's some code, please draw the code. And here I might have, for some of the more complicated ones, I say, here is your code, you know, here's the code, choose A, B, C, or D, which one is the correct output, you know? So, you know, trying to make it simpler for that, also make it easier for me to grade, to be honest. But then again, for some of those, but like for that particular question I have in mind, some of the multiple choices, the wrong answers will be less wrong than others. So there is going to be some partial credit allowed on some of those, just as an FYI. Wow, okay, that was open and that's weird. So, okay. Also worth mentioning that I received my like third email in 24 hours saying that somebody had either been exposed to COVID or that they have tested positive. So just keep that in mind. If you wake up tomorrow or Monday and you are feeling like somebody just, you know, totally stepped on you, you know, or you've been dragged through the mud or otherwise just ill, do not come to class. I know it's exam day. Just email me. We'll work out documentation issues if necessary later. Just don't come to class. I'd rather, look, it's twofold. First, I don't want you to get anybody sick. Second, these exams are meant to be an accurate representation of your skill level, an accurate assessment. I believe that is the word we use, an accurate assessment of your skills. I'm not going to get an accurate assessment if you're sick. Okay. Same thing goes on for students who will fast during Ramadan. I don't want you taking an exam while you're fasting. You'll email me and we'll arrange something, and we'll arrange this alternate time for that. Okay, because I need to have an accurate assessment of where you're doing, and being sick is not going to do you any favors, you know. So just let me know about that. That is really all I have to say about that. So all the kind of directions are out there. So we're going to work on this exam. So first off, true, false, computer science is the study of computers. False, what is it? What is a not wrong answer? Study of algorithms is not wrong, right? You're going to ask a lot of different people. They're going to give you a lot of different answers, but mainly what I'm looking for is a not wrong answer there. True or false, Alan Turing is often considered the first programmer. False, who is often considered to be the first programmer? Ada Lovelace, yeah. Ada Lovelace. As far as like first programmer, it might come out that somebody did something crazy early on and just didn't publish it as well known. That's why we say considered, because, you know, there's all sorts of arguments can be made. Same with first computer, but this is, again, a not wrong answer. And again, who was Ada Lovelace and why was she important? There you go. If you had to know any three names from a history of computer science, it would be Mohammed ibn Musa al-Khwarizmi, which is the person that algorithms is named after. You know, just simply, you can find that on the algorithm page. And you don't have to know all three of these people. I would know at least one of them. Hint, hint. Ada Lovelace, I would also know. And Alan Turing. It also might be worthwhile reviewing lab one, what you did for lab one. Also worthwhile noting that you have access to lab one while you're taking the exam. So, you know. Yes, question.
So set number 2 is false, right?
Yes.
And the answer is number 3.
Answer is number 3. She's often considered the first programmer. Okay, she was, if you want to go into more detail, there's she was Lord Byron's daughter. She died at an early age, but really the important thing is that she's widely considered to be the first programmer. Now, problem 2, so problem 4, or part 2 of these expressions. So this is the way this question is going to work on the actual exam. You'll receive 4, not 10, but 4 of these, okay, kind of expression things, which I'm about to go over. So you'll receive 4 of these. And then you'll also receive 1 of these true false questions, which will not be as nasty as this one. And it's not going to be as easy as this one. This one just exists to mess with you. But basically it's definitely not going to be as hard as this one, but something that's fairly not too bad. They will be worth about 2 points apiece for each expression. And they'll be fill in the blanks. Okay. So, and again, so a lot of these will be auto graded. The auto grader tells me if you're definitely right. It doesn't tell me if you're definitely wrong. Okay. So it's possible for you to accidentally like mistype something and it get caught, typed wrong. Or I might be like, for instance, example, the student, I might be expecting, let's see, for this one, okay, this is 6, 2 times 3 is 6, divide by 6, that's 1 times 100, right? So this would be 100, right? So if I'm expecting students to put in 100 as the answer, but if some student decides to put the answer is 100 in their blank, you know, the auto grader might say that's wrong because it's expecting 100, not this, you get what I'm saying? So, but will I correct that? Yes, of course I will. I'm not going to be a jerk about this. So don't panic if you put in the right answer and it marks it wrong. I will get to that and I will fix it. Okay. So this one, 1 mod 2 plus 3 mod 2. Here again, multiplication, division, modulo are all on the same level of the order of operations. So we do 1 mod 2. 1 mod 2 is 1 divided by 2. What is the remainder? 1 divided by 2 gives you a remainder of 1. 3 divided by 2 gives you a remainder of 1. So the question is what's 1 plus 1? It's 2. -1 plus negative 10.5. This one isn't too bad. It's negative 11.5. It's not a trick question here. And the nice thing about all these is that you can check them by dumping them into the interpreter. 4 plus 5 minus 3 times 2. So this would be 9. And then 3 times 2, which is 6, right? Well, we should do actually, sorry. We do 3 times 2, which is 6. So this would be 4 plus 5 minus 6. Should be 3, right? Okay. So this one, this is classic me, which is that I love to have a big, nice, big, complicated math and then either multiply it by 1 or 0. So which basically means that the math is unnecessary. Okay. Here we've got hard math to do by hand or by head or in your head, but we multiply it by 0. So this is just 0. So it's all negative 1.0. And for floats, we do want you to put down negative 1.0, okay? Over here, 2 times 8, this is negative 12 over here, right? And then over here, this is just reminding you that integer division is a thing. 7 divided by 3, that is quotient 2, remainder 1. So this is so 7 divided by 3, this gives you 2 over here, right? Because we're doing integer division. So 2 plus, and then we've got 2 times 3 over here, right? So 2 plus 6 is equal to 8. 4 mod 2. When you divide when you divide an even number by 2, you get no remainder. So this is 0. 0 times 3 is 0. And then over here, just kind of trying to teach you an interesting rule about arithmetic, about integer division, right? If you have a smaller number divided by a bigger number and it's integer division, your quotient's always going to be 0, right? So this is just a fancy way of me writing 0. If you haven't figured it out yet, your professors, myself included, are lazy. We like to have answers that are 0, 1/2, or 1 because the math is easy for us to check. This is true for physics. This is true for calculus. You will see this a lot, okay? As to whether or not you can metagame a test using that, it could help, maybe. It's a long shot, you know, but in a lot of math classes, they do want you to show your work. And then over here, times, this is just to remind you that that we do have an exponent operator and that exponents do have precedence over multiplication. So this is 10 squared times 2. So it's 200. 10 squared, which is 100 times 2, 200. All right. And now this is, oh, I see a answer in chat. Is it possible you can go over the modulo operator really quickly? The modulo operator, right? That is just simply going back to any time you see the modulo operator. Think about when you had to learn about long division. So anytime you had some number like, let's say 11 divided by 3, right? What you would have to do is that you do these operations, and then this was before you knew how to do division to get decimal numbers, right? What you would do is that you would say, okay, this 3 goes into 11, it goes in 3 times, and I'm left with a remainder of, well, right, 11 minus 9 gives me 2, so I'd say that the remainder was 2, right? And so the modulo operator, so when you're doing integer division, you get this. When you do modulo, you get the remainder. Okay, hopefully that clarifies things. The modulo operator is just simply, is just the fancy way of asking for what's the remainder. It doesn't show up in other, it rarely shows up in, it doesn't show, the modulo symbol doesn't show up in kind of math classes and stuff because they can just ask what's the remainder. But your computer, we like to use a quick symbol, so that's why. It's just asking what's the remainder. So what are the values of X, Y, and Z after these statements? So this is mainly just to make sure you understand how variables update. So we've got X is equal to 7, Y is equal to 8, and Z is equal to -5. Apparently I'm a jerk. Okay. So X is equal to X plus 1. So remember, what we do is that we basically plug in 7 add 1, and then we store what the result is in X. So 7 plus 1 becomes 8. Y is going to be, so it was 8 plus 8 plus -5. So this is going to be 16 minus 5, which is 11. So we're going to store 11 in here. And then this is the only real tricky one, which is Z plus equals 1. This is because we are incrementing a negative number. This means we are adding 1 to a negative number, which means, you're subtracting a value towards 0, I guess. Or sorry, you're moving towards 0. So kind of feels more like subtraction, even though it's a negative number, right? So -4. Okay. And that's basically what I'd want you to write on those. Whoops, sorry. I know some of you are writing it down. 8, 11, and 4. Again, I'm screen capturing this, so you can review yourself. So don't worry about furiously going over the notes. All right. So evaluate the following conditional expressions to be true or false. Okay, so first rule, true or, I don't care. I don't care. It said true or. That means only one of the sides could, that as soon as one side is true of an or statement, the whole thing is true. Not false, that's also true. Not flips the sign, essentially. It's the equivalent of -1. All right. So not expression and 3 minus 2. Oh, sorry, 3 less than 10. So so basically we do either side of this and then we try to figure it out, which is, so we do not 4 less than 2. So 4 less than 2, that is false. And then we flip, and then the not flips the false to true. So this side is true. And 3 minus 10, 3 is less than 10. That's true. Both sides are true, so this is true. All right, so this one actually, I wouldn't expect you to know off the top of your head. It turns out I used the practice exam to teach you things, because I never miss a moment to do that. So 32 divide 8 is 4, and 32.0 divided by 8 is, well, that's 4.0. So the question is, how does Python treat these things? Does it treat them as the same? Does it treat 4 versus 4.0 to be the same or different? And that's an interesting question. Like, they had to answer this question when they were designing the language. And the answer is that Python works on the principle of least surprise, which is that if two things should be equivalent, then they are equivalent. 4 is equal to 4, no matter how many decimal points you have over it, right? More technical answer is that in order to even compare 4 to 4, you have to convert that 4 into a 4.0. And converting a 4.4 to a 4.0 turns them into two things that are equal. So that's technically what happens there. So this is also true. I mentioned I was a bit of a troll earlier, right? So over here, this one is, again, just a big mega thing that I just made because I'm cruel, I guess. All right, so true or, so we've got a bunch of parentheses, so we work with in the innermost parentheses. So we've got parentheses around a true or. I don't care what this is. This is a true now. Okay, false or true, that becomes true. Okay, so now we've got true on this side and not true. So the not turns this true into a false. So we've got true and false. Both sides have to be true for the entire expression to be true. So this entire expression becomes true, but we've got a not hanging outside. Sorry, this entire expression becomes false. We have a not hanging outside, which then flips it to true. So all of our answers in total was true. I don't do this on the exam anymore. It messes with students too much. Practice exam, though, is perfect. Perfect place to do that. Right, and if, by the way, statistically, if this is just like statistics, if you've got 5 true false questions in a row, the chances of them being all true are 1 in 32. Not that low. So slices over here. This is useful to know, but I didn't put this on the exam. This, as I mentioned, we are only going up to, I suppose sequences did cover this, but I'm not putting this on the exam right now. We can go over this index of 3. So the index over here is, let's see. The index over here, so we have 0, 1, 2, 3, be A, and yes, you should totally write, you know, your indexes over there because human eyes are terrible at this kind of stuff. So, you know, make it easy for yourself. Okay, slicing. So the here for the slice notation, 3 up to, but not including 8. So index 3 would be, again, 0, 1, 2, 3, 4, 5, 6, 7, up to, but not including the space. So answer B would be apple. Oh God, I was cruel with this one. Let's see. So -2. So here's the fun thing. If you're coming from other languages, negative indexes work. If you're coming from other from nothing, then you know you just learned it as something normal. This is not something that regularly features in other languages. So second to last character was B over here. A, this we learned was A, and I already know what it is because I know myself. So this says from 1 to the end going down by 1. So this would be for A. So from index 1 going down. So this would be 0 and 1 going down. So this is NA, and then do 2 of those, it's saying. So the answer for this is banana. So this part's the hardest part. What this is that it is, so this part says, so basically you have when you do a slice, you have 3 parts. You have beginning index, you have ending index, and then you have your step. Okay. Here, the step was -1, which meant go backwards as opposed to go forwards. And here the starting index was 1. Now, now you can leave any of these blank. If you leave this blank, it's 1. If you leave beginning or end blank, it's the least surprising answer again. It's where it makes sense. So in this case, since we let the end blank, it made sense to stop at, you know, index 0, you know, include it. So it was just simply NA. All right. So, and it is banana because if I put 1 fruit in, I'm going to put another fruit in. And this one, this is similar from start at the beginning. So start at index 1 and go and take every other character. So it would be H, I, D, D, E, N, hidden, and then take the space and then message. For every other character we would print out or would be in there. Right here, you're going up by 2s. Again, slices aren't going to be on the exam, but they are darn useful. Okay. Yeah, this is more stuff that I would probably include in exam too. So take the function, takes in a string and prints out the string in reverse. Right here, what we let's see. Again, something like this won't be on the exam. This is like the only page that I think that's relevant, that this won't, sorry, there's 2 pages where this won't be relevant on the exam. This is one of the pages, the slices and the string and range. But these are still useful things to know. So what we're going to do over here is that given the text, there's a couple different ways we can go through this. We could just simply say, we could do a one-liner, which is that we could just simply print the string in reverse. Print text. And then the way you reverse something is -1 there. Remember, if the beginning point of a slice and the ending point of a slice are empty, then that basically says we're from wherever it makes sense to start and wherever it makes sense to end. So if I'm saying -1, that's implying I want to go backwards. So it makes sense we'd start at the end and go to the beginning. This is actually like the canonical way to easily flip something in Python. It's really cool. Because it's a pain in other languages, because you might otherwise have to work with an accumulator pattern like this. Okay, and it would work, and it would look something like this, which is def reverse. Let's see, print reverse, because there is a reverse function, but print reverse. Okay. Text output is equal to empty string for letter in text. This is another way to do it. You could go by indexes and go backwards to the indexes. This is one other way that you might not think of. But output. So first off, if we did this, output is equal to output plus text. Oh, sorry, not text, but letter. Basically, this says take the what's currently stored in output and add letter to the end of it. Okay. So if I did, which basically just clones what I had. So print reverse wolf. Okay. Okay, and then again, I said for the function to print it out, so print output, and this will just simply print out the same thing. It's not going to reverse it. Source must be saved. Yes, it must be saved. I'll go ahead and put it on my desktop. Exam review. Okay, there's wolf, and it gives me wolf. But this says take what we currently have as our output and add letter to the end of it. Something interesting happens though. That we can do. We can do it a different way. We can say letter plus the output. We can flip the signs, because for strings, adding isn't reflexive. It doesn't, it doesn't, A plus B is not the same as B plus A when we're adding strings. It's the same when we're adding numbers, but it's not the same when we're concatenating strings, right? So here what we're saying is take what we have in output and add letter to the front of it. So we would put the W in the front of empty string, then we would put the O in front of the W, then we would put the L in front of the OW, and then we put the F in front of the LOW. So again, there's a couple different ways we can slice any problem. Do I care which way you do it? Unless I explicitly tell you on the exam, no, I don't care. In the exam, if you're allowed to use every bit of knowledge you can muster, okay? If it's a library I haven't taught or a function I haven't taught, it's fair game unless I explicitly prohibit it. Okay, and I will explicitly prohibit it. Okay. All right, draw the result of the question of the turtle program below. So here, in the exam, I did this a bit better by telling you what the length I wanted was, but we can just basically I did pass it over here. So I passed Bob and 5 in. So Bob is going to be our turtle, and we're just simply going to replace length with 5 wherever we see it. So do the following 5 times. Okay, Bob starts here. We go right he turns right 45 degrees. So now he's facing this way and go forward 10, however many that is. We're moving forward the same amount no matter what. So it doesn't really matter. So forward 10, left 90 degrees, forward 10, right 90 degrees, and now right 45. So now he's facing up this way. Okay, let's see. And then we would say, right 45, forward 10, left, which would put him this way and move 10. So you can see I'm kind of making a pattern here, right? One pattern produces each of these. So we would just do this 5 times. 1, 2, 3, 4. So we've kind of got ourselves a sawtooth over here. Does it have to be to scale? No. Would I accept this as an answer? Yes. as messy as it is. Make sense? Oh, yeah, I would be turning right. I did left instead of right there. So boom, right, 45 degrees. Obviously, I was just testing you to see if you would catch that. All right, so yeah, that we'd be so in this case, we would be facing down, right, 45. So we'd be facing this way, then we go this way, and then we turn left 45 degrees. That makes more sense. So left would make us point up. So it's the same sawtooth pattern. So suppose you make the same mistake I just did. 1, 2, 3, 4. So suppose you make the same mistake I just did. 1, 2, 3, 4, 5. And instead of doing it, you write the right thing, but in the wrong orientation. Do you think I'm going to mark it completely wrong? No, I'm not a jerk. I'm going to take off a couple points, like depending on the amount of questions. Here I might take with 5 points. I might take off 1 to 1.5, depending on how I make my rubric. Okay. I'm not gonna, but are you gonna get completely wrong? No, in fact, you're gonna get mostly right. I care about, were you able to follow most of the code? Right. It's just a matter of, again, making sure that things are reasonable. Now, suppose I change the question to thus. What makes this change significant? In other words, what control or power does the programmer gain from from calling the function from the changes? So in other words, I change the question Ziggy to have a size argument, right? And you can expect something like this on the exam where I'll give you something to draw, and then I ask you, okay, I've changed it up a bit, or I've added a bit more to it. What does that do to the code? What can you now do with this? In this case, right, it makes the size of the teeth bigger, right? We were kind of drawing teeth or jagged mountains or points or however. It just makes the shapes, the individual, triangle points bigger. As long as you're able to communicate what's going on effectively, and that can include drawing that, right? By saying, okay, our original one was like this, but now it's going to be like this, and it could also be like this, right? As long as you explain that kind of thing and you're more than welcome to use drawings to do so, right? The point of communication is to be understood. Yes, turtles by default face this direction. They face in the direction of the positive x-axis. And what happened when I initially going over this, it said right, but I turned left, which I thought I sorted that out in kindergarten, but I guess not. All right. So draw the result of the program below. You will get a few of these where I simply tell it, which are essentially what is the output of this code, but it's easier to do this with for loops, I find. It's easier to test you on for loops when I have something that, it's actually entertaining for us to do. So now this one involves a nested for loop, which can be difficult for a lot of people. So now just keep in mind that especially on this exam, like later exams, I get a bit trolly, okay? And in practice exams in other parts, I also get a bit trolly, like over here on the Confundist question, where I completely swap up X and Y like there's nothing else, okay? But for this exam, I'm not going to be trolly. I'm not going to try to ask trick questions. I mean, I'm not going to, but I'm not going to deliberately write anything that's a trick. Okay. So that means that I will give you meaningful names. So when you see something that says 4 row in range 5, that means there's probably going to be 5 rows of something. This is a reasonable guess to make. I'm not going to give you meaningless names. And if it would be meaningless, I'm not going to name it row to confuse you. I'll probably call it Fnord or something like that, or some other, complete gibberish word, like for bop or for something that's completely unrelated to the question. Okay. Okay. For a row in range 5, what are we going to do? So we're going to do the following thing 5 times. Okay. except for dot in range row plus one. So we have to keep track of the values of row. So what are the values that row is going to be? So range 5 means that row is going to be 5 values over the course of its life. It's going to be 0, 1, 2, 3, 4. Okay. Each first time it goes through the loop, it's going to be 0. Second time it's going to be 1. Or if you prefer, the 0th time it goes through the loop, it's going to be 0. The first time it goes through the loop, it's going to be 1. The second time it's going to be 2. Right. So if you prefer to say it that way so you don't get mixed up, it's perfectly viable. Okay. So what we're going to do here is that we are going to say for dot in range. So current when we're starting out in range row plus 1. So we're starting out with row being equal to 0. So this would be 1. Okay. So we're going to do the following ones. Draw a stamp, which basically makes a dot. And notice that we said turtle.pen up here. This is very common with with stamp problems, that I'll just have the pen up. I don't mix the lines with the pen being up. So always, so always have stamps and pen up be together. So stamp, move forward 50. So the turtle's right here right now. And then I do some weird commands after this, which is Bob.right. He was facing this way. Now he's facing down. And then he says, Bob, move forward. So Bob's position goes from here to here. Bob.right. So he was facing this way. He turns right again, which faces him left. And then Bob.forward 50 times row plus 1. Row is currently equal to 0 plus 1. 50 times 1 is 50. So we move him here. And he's facing this way. Bob.right 180. So I'm making this fairly straightforward by making us do a 90, a 90, and a 180 all in the same direction, which adds up to 360, which means that when we're done with this, he's facing the same way he started. What did this all do? It moved him right below his start position. Okay. So now what we've got over here, let's clean this up a bit, is that we've got row is equal to 1. Bob is over here. So for dot in range, row plus 1. So this row is currently equal to 1. Bob is right here. He's going to stamp his position. He's going to move forward. And then this is 1 plus 1. So we do this 2 times. So again, we put down another stamp and we move forward. Then what do? We turn right. We move forward, which means we move him here. I'm just using the X's to note his current position. They're not stamps. Turn right 90 degrees again. So he's facing this way. And then he moves forward 50 times 50 pixels times row plus 1, 1 plus 1. So he does 100, which is 50 times. So he goes 150, 250. So he ends up again back where he started at the beginning of this beginning of this iteration. So you end up right there. And so by this point, we should be seeing a pattern because turtles are good for patterns. So here row is equal to 2. So this is 2. So 2 plus 1 is 3. So we do the following thing 3 times. 1, stamp, move forward, stamp, move forward, stamp, move forward. Turtle is here. Make sense? So now we do Bob turns right. Bob moves down over here, and then he moves forward 50 times row plus 1. And at this point, you should note, this moves him forward. This loop moves him forward 50 times row plus 1, right? This loop moves him forward 50 times row plus 1. And this moves him backwards, relatively speaking, in the negative X direction, 50 times 1. Make sense? So this moves him forward. This moves him the exact amount backwards. Right? And so now he's here. So the eventual answer we settle on is 1. Then he does this. Now, I do try to make pretty good rubrics for these kinds of questions, such as like, okay, did the student have the right number of dots per row? Like, for instance, if you ended up with doing this, or, adding another layer, that's depending on the number of points that is, that can be, not all, it's not going to be half credit. It's going to be like something like, a fifth of the value off or something like that. If there's something, and it all depends on what weirdness I decide to do with this, but this one I would study. This one I would definitely study, because this one is good because it's got not just a loop with one repetition, but it's got something that varies as we do it. This isn't going to be horrendously complex. This is going to be, when I'm drawing symbols with dots, you can expect like triangles and squares and rectangles, those kind of things. Those are the kinds of things I like to do. Okay. Like very basic shapes. All right. So down here we have a question. Complete the function so that the turtle is passed in an argument that draws a square. Each side of the square should be sidelong. We've done this a lot of times. Now, I might give you something like this. But also I know for a fact on the exam, one of the questions I do have is something where I give you something like this or like that. I give you a shape and I give you code with some blanks in it. And I basically ask you to fill out the blanks appropriately. Okay. Okay, so here you're right. I'm giving you the output and asking you to write the entire input, which is tougher. Also note over here again that I drew 4 squares. There isn't like, this isn't there, the squares are for this question going to be this square, this square, this square, and this square. It's not, we don't have like, this isn't one of those puzzles like how many squares do you see? You see 1, 2, 3, 4, there's not like 8 squares or 10 squares or however many in here. There's just 4 and they happen to overlap and create more. Okay. So for this one, draw square. What are we going to do? We are going to go to our, draw square. You'll notice that the actual amount of coding I'm having you do in this exam is fairly minimal in terms of the amount of code you write. This is deliberate on my part because at this point for people who just started out, it is more fair to basically ask, are you understanding the code by reading it? Second exam will definitely be having code where I ask you to write some functions that do things. So draw square. So let's go ahead and say, right, we need Bob and we need sides or side. What did I say the variable was? Was it side? It was just side, 1s. Doesn't really matter if you change it up like that, as long as, again, answering the question. Import turtle. Okay. Colon. Bob dot. So now we do a for loop for I in, or for whatever. You can put whatever you want there, for in range 4. We just got to do it 4 times, right? Again, here, we're not making, again, we don't have, I'm not letting you have access to code writing in this. I said no editors are allowed, right? So that's a part of the reason I'm not making you do it. And as a result, I will grade you very differently as though you had, versus if you did have an editor. Like if you wrote this but forgot the in, that's going to be barely worth my time in terms of knocking a point off. Okay. Those kind of things, I'll be like, aha, they were moving quickly. That the only thing that might affect is that if you have if your answer is otherwise perfect, you might get a 9.5 out of 10. Those kind of things don't really, And I'm not gonna even like bother like dinging you for multiples. I'll just like say, okay, this is just almost a perfect answer. And they would have obviously corrected it if they had access to an IDE or an editor or something that would have just told them that they had an error. Okay. For blank and range, Bob dot Ford. This side length. Okay, apparently I'm having trouble spelling today. Bob dot side, Bob dot. All right. 90. So move forward, turn right, move forward, turn right, move forward, turn right. So he ends up back in his original space. Okay. So what do we have to do for this picture? So let's see. So the turtle drew 4 squares. Okay. Let's see. Now this is mildly tricky by the fact that Bob is kind of over here. Man, this question probably would have been a lot easier if I put him over here. Yes? Maybe? No. No, it would be more, you can put him over here. So let's see, we do 1. Nope, it's exactly where he's exactly where he needs to be. Because what we need to do is that the way we've been doing circles, squares in class is that we've been doing this. We've been doing a square and then Bob ends up where he started. Okay. Now, because it's going this way, it makes sense that Bob should be turning right as opposed to left, because if it was left, we'd be doing dot, dot, dot. Makes more sense. Yeah, we'd be basically drawing stuff up. Doesn't really matter, though. Point is, Bob's going to start. We can assume that Bob starts in this. We can start Bob wherever he needs to, but we'll draw our square here. And then we got to get Bob down to here so that he draws his next one. Make sense? Then we do the same thing. We get Bob down to here to draw the next one, Bob down to here to draw the next one. Then at the finals one, he draws this, and he does nothing different than he would normally do. If he had to draw he goes here, which is the appropriate place where he would need to if he drew a 5th square, right? So this is 4 squares. So we're going to make 4 exact motions of this. So basically to draw this, it's basically draw square, pick up, and then end up over here in the center of the square. That's basically what this is saying. So in order to do that, we need to do it 4 times. And then what we do is we just simply do that 4 times. So I will draw as I'm doing this. So I will not run it, but I'll run it at the end to kind of confirm that we do have the right answer. Def, I'll call it 4 square. 4 square. Okay, doesn't take in any arguments. I'll take it. Well, I'll take in Bob as our argument. Doesn't really matter. You could do this as a function. You don't have to do this as a function. Oh, let's see. What did I say? Yeah. Oh, yeah. Using the draw square function. Yeah. Don't even have to use this function other than the one that you wrote. So what he does is that Bob is the first thing he's going to do is that he's going to draw a square. And we can, and honestly, it doesn't matter how big it is. Bob. And let's call it 100. Go ahead and actually say it's side. Yeah, side is equal to 100. And then we'll just do it over here. Why? Because it makes the numbers easy to change and prevents me from hard coding answers in. So once we do this, we are going to we're going to be here. This will be the status of what we have once we've drawn everything. So now we need to get here. Now to get here, we have to go half the way across and half the way down, right? Now it's helpful that I am here, right? So what I have to do is that I have to, let's see. So I'm going to go, and yes, I know what I'm doing here. I'm leaving something out. Bob.Ford. Side divide by 2, so he goes half the way across the side. Bob dot right 90 degrees to turn down. And then he's going to move forward halfway down the program. Okay. And then he needs to turn back to his original direction. So Bob dot left. And if I work that on my own, I get draw this, I draw the square, then I get Bob going this way, and then he goes down. Which if we check our calendar, he goes across. Not calendar, our original drawing. He goes across. So he draws a square. He goes halfway across, and then he goes down to the center. Down to the center. I drew a line where I shouldn't have. So we have two parts. So again, two parts of this problem. Easy to split up into two parts, which is draw the square, then move to the center. For moving to the center, the way we handle that line, just pick the pen up. And then put it down for the next one. So Bob dot, oh, I should probably start it over here because we drew our square and now move to the center. Bob dot pen up. Bob dot pen down. Okay, there we go. Bob dot pen up and Bob dot pen down. So now he's moved to the center. And now we just repeat this 4 times, right? We could simply just do this 4 times to say, 1, 2, 3, so to repeat it 4 times. But again, that's kind of tedious. If we know we're going to be doing something 4 times, then we should just, toss it in a loop to tell it to go 4 times. So 4 in 4 blank in range 4. I knew I should have grabbed my keyboard from upstairs. Okay, and now indent that in. So this will run 4 times. Now I'll go ahead and now again, you are not going to have access to this during the exam. But I'm just going to confirm that this works for you. Turtle. Again, what I had to do to confirm this worked is I drew the steps out as I was doing them. It also doesn't hurt that I wrote the question and that I've done it before. So let's see. And it's not moving, of course, at this point because I didn't tell it to do anything. I just simply said create. I defined the verb, the new verb in the language. And then I told the turtle not to do, and then I said, make a turtle, and I didn't do anything with it. So that is something that will happen a lot. And as soon as it happens, the more you do it, and the first time you do it, you'll be like, what's going on? And then the 5th time you do it, you're going to know exactly why it happened. And you're just going to go and quickly fix it and think nothing of it. And there we go. And that is also just how I got my image of that. The only difference is that I made him a turtle, which you don't have to add. I just did that for cuteness sake. Okay. Similar question over here. Let me just check what we have left before I go back to it. But over here, we're just drawing 4 squares. What we do over here, what happens over here is a bit different, but the same thing applies. Let's see, foo confundus over here. Yeah, so this is the turtle here is the most in practice. The other stuff can be useful, but it's not nearly as useful or relevant as this turtle practice over here. Okay, so here, again, there are 4 squares here, not 5, even though it looks like there could be 5. But let's think about how we could do this. So we draw this over here. And then let's see. What happens if we try to move our turtle over here? So we get the turtle to be over here. So let's move the turtle to the center again. Yoop. Okay. Now what we did for our turtle is that we faced him this way. Right? And then if we faced him back to where he started after moving to the center of the, moving to the center, he did the last one. He did the whole making this, you know, pattern of squares connected at the center. But if we move so if we draw the square and then move to the center of the circle, turn right, and now, so again, he didn't turn left again. He's still facing this way. If we tell him to draw a square, he'll do this. And then we can move him to the center over here. So basically, it's the same. So it's the same question. But if we leave out a line, we get radically different results. The same logic applies here. Actually, it's a bit harder logic, even though it's less lines. So it's the same program. We just don't turn left. The turtle just keeps facing the same way. I know there's kind of a cop out there, but it makes you think is the point. And now what if you didn't do it this way? What if you did it some wildly different way? That's also valid. Again, what I care is did you answer the question? If you answered it in a completely different way than I expected it to happen and it still works, then I'm happy. Okay. There's a lot of different ways to do them. Some are better than others in terms of ease. But again, it's an exam. You're trying to do what you need to do. Now, before I move on, I just want to clarify a couple things. So the exam for this first one, just to simply help with any kind of, you know, first exam jitters, the exam, rather than being 80% during like the rest of your exams, the solo exam will be worth 70% of the grade, and the group exam will be worth 30% of the grade. So a bit of a higher bump there for that. And again, if you miss the group exam, and again, the group exam can't hurt you, but it allows you to correct things there. This group of questions for this group of questions is a bit trickier than I would normally ask. That second one is trickier than I would ask on the actual exam. But I can say that like this would be like the kind of pairing I would like to do. Like if I asked this during the exam, this would probably show up on the group exam. Where they both use the same function to do the same thing. And I'll try to do that. All right, so now let's move on to these other questions. What is the output of the following question? So this is what I mean by using nonsense variables when I don't want you to know what the variable names are, where variable names could give you an answer. Again, if you see nonsense variable names, just know that they're nonsense. If you see real names for your variable names, know that basically that I named them deliberately so as not to trick you. So we have three functions. We have foo, which prints foo. We have bar, which calls foo, and then prints bar, and then calls baz. Then we have baz, which prints baz and calls foo. Okay. Now, for those of you who don't know, those are what we call metasyntactic variables, meaning that they are variables that just are placeholders for other variable names, because we can't think of anything different. It comes from the term foobar, which is short for something like fouled up beyond all repair. There's a number of or beyond all recognition. There's a lot of variations to it. If you get 100% of the solo, do you have to do the group part? I suppose not, but you're going to be missing out on an opportunity to truly master what you've learned by teaching it. And teaching something is the way to doing mastery, although I'm biased because I'm a teacher. So, you know, I freely admit that. So there we go. So foo. So we've got foo, we've got bar. And we've got bars. Okay, so foo prints out foo. Bar, when we call bar, the first thing bar is going to do is it's going to call foo. Foo says print foo. So now foo is done executing. So this foo is done executing. So we're now back in bar. Second line of bar says print bar. So we do so. Then the third line of bar says call Baz. Baz says print Baz. Okay. And then call foo. And foo, as we know, is just short for print foo. So we're done with bar finally. So we finished Baz, we finished bar, we finished the Baz inside bar. And now we finally print, come down to Baz, which says print Baz. And then call foo, which prints foo. So we got foo, foo, bar, Baz, foo, Baz, foo. The point of this is to note that functions can call functions. Yes. No, because when we have a print statement without any kind of anything extra added, it prints what it needs to, like foo, and then it goes on to the next line. Yes. Because Python's clever like that. It says I see a function, hopefully. So Python is lazy, and it basically says, aha, I see Baz. What function is Baz? It knows it's a function because it's got parentheses after it. It says, I'll figure out what Baz is when I have to call it, because it may have, because here's the tricky thing about Python, it may have changed between times you call it. Okay, but the point is that Baz, as long as Baz is defined when Baz is called, that's all that matters. When it's actually called is when it matters. With C, yeah, you have to declare things before you use them. Before you call, you have to declare functions before you call them. Java's a bit looser with that, I think, if I recall correctly. Yeah, but here it's fine. Again, it only matters when you call them, and that's, again, like I said, one of the looser things about this language, because you can do things like redefine functions, or store functions and variables, because Python treats functions like first-class citizens. Now, the second question, of course, is what if we change Baz to the following, which is this? Which is that we add bar. So that was the other question. We have we have all the stuff. It's the same thing, except I change Baz to call bar. So what happens in this case? What happens with the output now? Anyone? Not a trick question. What would, yes. It does just go on forever. It does just go on forever. It's an infinite. What you've got here is just basically you have Baz, you have bar, which calls Baz, and Baz calls bar, and bar calls Baz, and Baz calls bar, and bar calls Baz, and Baz calls bar. It's actually harder to say than you think it would be. So you just have these two functions that you have function one calling function two, and function two calls function one, and it just keeps going back and back and back and forth, and you're stuck in an infinite loop. It will last forever, barring the fact that I think in this particular case, it will actually last until you like turn off the computer or whatnot. So in this case, this is an infinite loop. Infinite loops are a bit harder to do in Python, mainly because in Java, you can just leave off a variable or set your conditions wrong for a for loop and it goes on forever. This time, because your for loops in here are iterators, it's a bit longer, but you're still going to occasionally counter the odd infinite loop by accident. So if we change Baz in the above example, the following, what happens, it becomes an infinite loop. Now with 17, this serves a very important purpose that I will hammer again. Expect this kind of question on exam 2, but I'm showing you on exam 1 because it's an important concept to understand, which is that when I wrote draw square and I pass in a turtle and a number, how does it know which is which? It doesn't check the type. What it does is that it checks, what it does is that it gets passed in positionally. The first thing it accepts, it's going to assume that it's a turtle. And the second thing it's going to assume, well, whatever side's role is, right? It's up to the programmer to make sure that things are passed correctly that way. It's the only kind of way it works. So in this case, with Confundus, well, this tests two things. First, arguments are positional. Second, it's passed by copy, as we say. So, which is intentionally confusing because while it's passed by copy, you'll soon learn that everything is an object, and thus objects are passed, and objects pass themselves by copy their references in, which means you're copying where to find the exact same thing, and it just becomes a whole rabbit hole. But we don't have to worry about that now because we're dealing with numbers. The point being is that we've got x is equal to 6, we've got y is equal to 8, and we've got z is equal to 4. Okay. So for this one, Confundus, we call 4, we call 6, and we call 8, conveniently in numeric order. Now, here's the thing. This is not 8 and 6 and 4. It's not 8, 6, and 4. The fact that these are called ZYX, and these are this is ZYX and YXZ and XYZ over here, they are completely unrelated to each other. Or these X, Y, and Z over here are completely unrelated to these over here. And the fact that I didn't name them different things is bad programming practice on my part. Things are passed positionally. Basically, when things come into, so the way to think of this is that when things get passed into a function, they all get passed name tags. They're all given name tags. So 4 gets passed into this function and it's given the name tag y. It had the name tag on the outside world, it had the name tag z. In here, it's going to also wear the name tag y. So 4, 6 gets x, and z gets 8. So it's 4, 6, 8. So ignore this now, because this is all irrelevant down here. 4, 6, 8. So x, so we look for x. X plus 1 is 7, so this becomes 4. So let's see. So go ahead and increment this value to 7. Okay. Next, we have y is equal to y, which is 4, minus x, which is 7, plus z, which is 8. So 4 minus 7 plus 8, we can reverse this, and we know that this is just simply adding 1, which would be 5, right? So negative 7 plus 8 is, that's 1, so 4 plus 1. So y becomes 5. And so now what we print out is z, which is 8, x, which is 5, and sorry, not x, z, which is 8, x, which is 7, and y, which is 5. Again, this kind of thing was intentionally made to be confusing. And I tell you that it was intentionally made to be confusing. But it's all to understand that these things are all passed, these are all passed by position. Okay. So let's take a look at this one. So we can do 17, 8, 2, and then we're going to pass in 17, 8 over here and 2 over here, which means that this is 17, 8, and 2. And there's a whole bunch of math, which none of it actually matters. The answer is 1782. Why? Why does none of all this confundo matter? Why does this not matter? Yes, there's no print function inside there, right? All this stuff gets copied over, right? We copy 17 over, we copy 8 over, we copy 2 over. None of that reflects back on the and modifies anything that happens here. When variables get passed, they are passed by copy. They pass copies of themselves in. So we can make all the changes in here all we want, but it's not going to affect our actual integers. Now, what we will learn, and what's going to sound like an immediate contradiction, though, is that if we pass in a list, that can get changed, because when we pass in a list, we're passing in a reference to the list, the memory location of where we find the list. Yeah, I can see some of you going, oh, no. But we will come to that later. The point being is that vast majority of things, they pass by copy. Actually, everything passes by copy. What you are copying depends on what it is. For integers, it's just the number you're copying. For everything else, for everything but for an integer or float, or a Boolean, it's gonna be a reference to the object, right? We saw that with Bob. When we passed Bob in, we didn't suddenly clone Bob. Sorry, when we passed over here, when I pass T into this function, it doesn't suddenly become a new turtle. I don't copy and create a new turtle. There aren't two turtles on screen. What I'm doing is what you got to understand here is that this is a variable, T. What gets stored inside the box that's labeled T? We don't actually store the turtle in it. Instead, we store a little slip of paper telling us where to find the turtle, and that's what gets copied over. This is the way that everything works that's more complicated than numbers. Doesn't really, it's something you intuit the more you work on, the more programming you do, but you'll see how that works. But again, keep in mind that all numbers are just passed and copied over. All right, let's write a new function called print threes, limit, which prints all the positive integers less than limit that are divisible by 3. If limit is less than or equal to 0, print nothing. So we can solve this with a fairly straightforward for loop. I will not subject you to my handwriting. So what I will do is I'll just simply, this is everything, all positive integers that are up to, but not including limit, divisible by 3. Okay, the def. So again, a harder question than I would normally put on this first exam. So what we're going to do over here is for I in range. So first off, if I were to do this, if you can't answer a question, try answering an easier version of the question first. Okay, instead of printing all numbers up to 3, so all numbers that are divisible by all the numbers up to limit that are divisible by 3. Instead, let's write the question. Let's answer a different question. Print all the numbers up to, but not including limit. Now from here, we have multiple different paths to victory. One way is, well, I could try you're like, what if I do times 3? Then I would go like 3. I'm sorry, then I would go 3, 6, 9, 12. I'd have to stop a bit earlier, but I think that would work by just dividing this by 3, right? One possible path to take. The other possible path to take is you're like, okay, I'm going to start at 0, going to go up to, but not include limit. And I'm going to go up by 3s. That's another way to do this. There's a lot of ways to solve this one. And again, I'm not really, I don't really care which one you do, so long as it works. Now, with that, we've gotten into the additional practice. So now with the additional practice, I should mention some things. These are questions that I've done for homework or in-class exercises. This one in particular, a bit more difficult than I would do in an exam. printing out a descending triangle of numbers. The way you solve this one is by you're printing out the numbers, starting at 10, going down to 0, but not including 2. But sorry, starting at 10, but going down to 0 by 2s. And we do 8, 6, 4, 2. So basically what happens is that you're subtracting 2 from the starting number each time you go through it. So it's a nested loop. In order to do anything where you've got a repetition, but with minor modification, for instance, each time here we're doing one less number, that's a minor modification, right? We need a nested loop. Same thing over here. It's just we've got a different start. We've got a different, instead of going down 10, 8, 6, 4, we've got 10s at the beginning at all of them. And we are changing the ending point over here. Now over here, I wrote Project Euler Problem 1. As I mentioned last time, that's a website, very good website. Okay, apparently I hit the hotkey to rotate it. That was interesting. How do I even do that? What was that hotkey? Let's see, rotate counterclockwise. Project Euler, again, is a great website for this kind of stuff. Multiples of 3 or 5 is problem number 1. This is a great question to kind of make sure you understand all the fundamentals of one programming language, which is this one teaches you how to do print statements. It says, do you know how to do print statements, and can you do if statements, and can you do for loops? That's what this one is asking. So it's good practice there. Don't need if statements for our exam. If you did, I'd be doing something like modifying color, changing color there. Okay. So it's 3:15. And for those of you, let's see, who stayed to the end, I'm going to give you a little gift for the practice exam. I'm going to tell you one of the questions I'm going to write. I'm going to ask on the practice exam, so you can come with an answer prepared for the, sorry, not for the group exam. Okay. So let's go ahead and start recording. Of course. Okay.